Hello, Karuna ji. Hi, Sumit. Can you hear me?
Hello.
Yeah. So, can you please test by sharing the PPT?
Hello, sir.
Can you hear me?
Yes, sir,
Yes.
I can hear you. Sir, can you hear me?
I can hear you well. Can you please share the PPT that you want to share or something so that we can test? Because we
Yes.
have 2 minutes remaining. We are right now live.
Okay. So, is my screen visible? So, is my screen visible?
Yeah, it's visible.
Okay.
You can stop sharing now. You can start later on. Let me just initiate
Yeah.
the session. It's already 12. So I think without any delay, we can start. Okay. Good morning, everyone. Welcome to the session, the first session of the training part of Manthan. And today we are having with us Ms. Karuna Lakhani. She is researcher, CTO, and founder of Karnel Solutions, a data scientist with certification in SAS, machine learning, and programming languages like SQL, Python. She is also a certified Neo4j professional with expertise in Hadoop, machine learning, neural network, graph database, and data mining. Hello. She is also having an experience in data integration and NLP. So that is the reason she selected the problem statement that is mentioned on your screen. Now, to state the quest for novelty, she concurrently continued to research and publish a paper on how to use word embedding to analyze system logs at the SMCE 2019 conference in Italy. Additionally, she has also worked on Azure ML, AWS ML, and Docker that we are going to use for this month. And based on her interest and capabilities, she wishes to contribute to the revolutionary technological development individually, hence founded an AI research-driven company named as Karnel Solutions. Welcome, Karunaji, on this particular podium of Manthan, the India's first national security-based hackathon. Welcome.
Thank you.
Okay, so without wasting our time, let me just quickly give a glimpse of the problem statement that we are going to cover for this particular session. It's like tracing of artificial fingerprints. That is the problem statement in the Manthan. So I'm just handing over the podium to you, Karunaji. We are having team leaders and team members of Manthan who registered so far, and they are eagerly waiting for some of the instructions on this particular problem statements. I request you to please guide them in a manner so that like they can perform well in the idea submission process, and if they are shortlisted for grand finale, they can come up with the best possible solution. Over to you, Lakhani.
Thank you, sir. So, hello everyone. And today, as sir rightly said, that we'll be talking about artificial fingerprint detection. And we will start the session. I'll share my screen. Okay. This is one of the topic which is there in Manthan, which is a national security hackathon, or let's say the first national security hackathon which is happening. And we will be talking today about detection of artificial molded fingerprints. To be honest, we will first go through the objective, what the objective of this states, and then we will slowly and gradually learn about the problem statement. If you need to have an idea, you need to know about the problem statement. So what problem seeks and what are the possible solutions which you can explore. So we'll talk about objective. We'll purely discuss more about what objective statement states, and I'll also be discussing about a small solution which I have put up, which can be one of the solution, but that's just a demo solution for you to understand how we can proceed forward with the topic. So if you go, every detailed thing is available on the website. But still, to start, we will first look into what the objective is. The objective statement is very clear, and it says that we need a biometric authentication. So biometric authentication is something. For example, you have your iPhone, you have your Samsung phones, you have your phones where you use your fingerprint to unlock the feature or unlock the phone. So we need to have the similar kind of an authentication system which can also detect whether the fingerprint which is scanned is actually of a real person or it is being molded. Yes, you guessed it correct. Molded fingerprints. What are molded fingerprints? How are they being formed? And how does authentication happen exactly? We'll go through step by step. The basic objective is very simple, that we need to have an authentication system which can also detect whether the fingerprint which is being scanned is actually of an individual or a certain kind of mold is there on top of it. If you would have seen a Tom Cruise movie, he had used a mold long back in 2001. So yes, those kind of techniques do occur. So we have to protect our self or our all the systems by actually detecting whether it's a fake, somebody's using molds, or it's a real fingerprint. The problem statement can also be rearranged and set as vitality detection and fingerprint identification. So what vitality is? Vitality is to the capability of the system to understand whether what something is happening is alive or not. So it's also called as spoofing. So there are different terms you will find at different wherever you will go, you will research, you'll find different terms for the same meaning. At the end, the goal of every such detection is to identify whether the molds are being used in identification of a fingerprint. Uh, it's long back, many scientists already said that, when we go in the near future, biometric authentication will play an important role. Since we in India are going for a digitalization era where we are shifting from a pure traditional way of working to a digital way of working, we need a strong authenticators at everywhere. We need strong authenticators at the banking level. We need strong authenticators at a personal levels. So all the data, all the information which we share use in a digital era, we need an authenticator to protect ourselves, to protect the security of every individual who is here. So that's why it is also called as a vitality detection, where we have it gives a capability of the system to detect whether any kind of spoof is being done. What is spoofing? We'll go gradually and see step by step. Let's understand exactly what is the technology today being used for a biometric authentication. See, all these things, if you go through, only then a different solutions will come up in your mind. The first thing, the current technology, which is very simple. If you would take, it uses an optical sensors. So we have a finger and the optical sensors with the light. It can be any light. It can be a laser light. It can be normal light, or it can be near infrared region light. Any light which falls on the finger, it captures the reflection of the light. And when the reflection of the light is being captured, the shape or the ridges which we have on our fingers are being captured and saved. So it's basically a pure reflection of light-based technology which we are using. And it is said that every individual has a unique pattern of ridges. My pattern cannot match with anybody else. This pattern is unique for every individual. So that is why it was being used as a biometric authentication traditionally. But it's a technology, right? So every technology have certain loopholes, and we discuss about those loopholes also, and then we'll move forward with the solution. This is what actually happens if I told you the ridges. What is the algorithm currently which is used? It's based on the patterns which you have on your ridges, on your thumb, on your fingers, anywhere, wherever you give a biometrics. It's based on the pattern. If you see on the screen, right there over here, the ridges, the lines which you see, they have a different meaning. Every line has a different meaning, and every pattern. There's a start of a ridge, end of a ridge, and there's a pore, the delta, island, everything. So pore, what is a pore? It's a hole in the skin. So skin deformation is a pore. So even those things are captured using lights, near infrared lights or laser lights, any kind of lights which technology uses. These pattern based recognition or identification is traditionally used, which is also called as minuty, which uses the pattern which you can see on the screen. These are captured and then they are being matched. So first time when you go, for example, you would have gone to a bank, or maybe for your Aadhaar card KYC, or for your phone these days, they always ask your fingerprints to be scanned. That's because if second time you go and get your SIM, if you've lost your SIM, and if you go back and then again ask them that you need to duplicate SIM for the same, they're gonna ask or verify your identity using your biometrics. So how important it is for that biometric to be authentic, because every walk of life we are going through this. Every whatever we go, whatever we process we do, everywhere we are giving a KYC using biometrics. So even banking, which is very important and crucial for everybody in today's walk of life. So our main problem, our main concern today is the attacks. The attacks which happen on these kind of systems using artificial fingerprints. We'll talk about what are artificial fingerprints. I'll give you one live example. If you can see, it is already available to see. You have a lot of videos also concerning this. It's a Samsung Galaxy S5 phone. If you have it with you, you can actually, even with a small hack, you can create a mold and try to access your phone with that mold. You will be able to. And there was an incident which happened where PayPal is again a gateway for transactions. So the PayPal took advantage of this situation, and there were hackers. There were hackers who could hack other people's information using this mold to do a transaction. So if you are using any kind of biometrics for your banking, please make sure that you have other verifications for now. And you can see how much important, even the glue mold is a Fevicol mold made from a Fevicol. So the scanner can also be hacked with just a glue mold. That was a Samsung Galaxy S5 scanner. Obviously, technologies have evolved now. If you would try this on a later versions, it might not work. At least the glue mold, but that era, even glue mold was working. So let's see how spoofing is done first, because to identify if a spoof is being done or not, you need to understand what materials these spoofs are made up of. And I'll also give you a very idea about these materials. When you use these materials, you can actually detect whether what kind of material is there on the surface. So if you're coming up with a solution, coming up with an ideas, you can also think about these ideas where you can actually identify different materials being used, again based on reflection using some AI techniques. We'll go through the solutions later, but let's come up with what spoofing is. It's a process where we are defeating a biometric system through an introduction of fake samples. So we're giving fake samples. If you can see on the screen, in 2019, Korean woman, she publicized the spoof attack. She publicized how did she spoof a system, and that to a Japanese system at the border. So she had spoofed the system at the border. So how much of a concern it is for everybody's security. And you can see what she has done is she has just created a mold. The mold of a fingerprint of somebody else's identity, and that mold is used for biometric authentication. So obviously today's, if you would come up with a ratio that how many number of such events occur, we don't have such numbers. But yes, you can the thing which you see on the screen are the different materials which can be used for spoofing. Example of clay dough, the clay dough which is used by kids. Even that can be used as spoofing, because that clay dough also um, captures your ridges, and everything is based on the ridges. Right now the authentication system is only based on the ridge lines which we have on our fingers. And so so we have to come up with a good solutions. Materials which can also be used is silicon materials is used, and I said glue is also used for such things. So there are different materials which are being used for spoofing the biometric system. And I'll also tell you the techniques which can be used. These techniques you would know because you can target a particular technique or different techniques. One solution or one algorithm might not work for all the spoofing techniques done. So you need to know what are the spoofing techniques, what is being used in those spoofs, and how to tackle them. This is our main objective, to tackle these techniques. So we need to understand what all can be used. As I said, the clay dough, which can be used, any kind of information, gelatin, paint, uh, latex, rubber, paper, any information where your any substance where your ridgeline information is stored can be used for spoofing. Dental material cast. You might have visited a dentist, and the dentist takes your cast of your teeth. So that casting material also can be used. You can see there are a list of materials which we can use. We can transparent film, where a film has also captured your ridge, and silicon wafer. Silicon wafer which is used to generate chips. The Intel chips are made from silicon wafers. So even those chips can be used. Photosensitive chips, silicon wafers can be used. So a different form of cast, liquid material to form a mold. At the end, what are they trying is, out of all these materials, they're creating a mold which has an information of your finger ridges, your finger patterns, and that mold is used to give an attack on the system. Uh, Again, you can see these are the different scans, optical scans from a scanner, a fingerprint scanner, and the top row, you can see it's a latex paint. Paint is used for capturing the information, ridge lines. Gelatin, you can see even the minute details of your hand are being captured using this mold. And in the bottom, you can see a dough, which is like you would get it. It's very cheap in the market. So that dough also captures your rich patterns. And silicon. So it's very difficult just for the pattern-based algorithms to identify whether the person is an impersonification, like the person is attacking the system, or is a real person, whether it's a live or it's fake. So it's very difficult. and that's why we are here. We are here for the same thing, to be able to identify. With bare eyes, even I cannot identify whether the fingerprints which are there are real or fake. Obviously not with bare eyes. And even if we use the scanners, even they are failing with the molds. I'll also give you a real examples of photos of a spoof fingers. So what they do, you can see there's a finger, and on top of that, various material molds are stick on your fingers, and that will change your pattern. The pattern which now will be observed by an optical scanner is the mold pattern and not your finger pattern. So as I said, paint, cork, Play-Doh, silicone, these are the highly commonly used materials for molding, for creating molds of your fingers. It's actually an artificial finger, you can understand. They just create an artificial fingerprint out of it. And usually thumb is being used. So usually you'll find that, I'm just putting up my thumb up. So when these kinds of attacks happen, we need to also understand. Now we have come through a point where we know what is our objective, what is the drawback of a traditional system, and how attacks are captured, what mold substances are used. And now what we will do is we will actually see a schematic diagram of what traditional fingerprint system used, what they do. It's just a diagram where I'll explain the process of what is being done at the back end at a scientific level. So this was an overview. Let's see traditional system, what it uses. In a traditional matrix for a biometric evaluation, we are only using one finger input, which is our finger input, whatever is there. I am not sure whether I'm using a mold. I am not sure whether I'm using a live fingerprint. Whatever it is a finger. I'll consider this as a finger. And what will happen is, the first thing is a data capture system. Then we have a presentation attack detection subsystem, and then we have a comparison system. So we have three systems where we capture the data, then we present if the attack is being captured, attack is being done or not, and then we compare. But in the traditional system, as you can see, the liveness detection module is not there. This is not there in the traditional system, which we will discover later on what is to be done. So what you do is you scan your thumbprint, and your biometric characteristics are recorded by a biometric sensor. So it's a hardware which can sense your ridges, your fingerprints. Okay, and it captures the information. If the information is captured correctly, you would have seen a lot of times when your age grows, like older people, there are less patterns in old people's fingers. So biometric sensor cannot capture all the patterns from them, and it fails. You would have gone for an authentication somewhere for a KYC. You would have seen that it was very difficult for your grandparents to record the thumbprint of your thumb, because the ridge lines had vanished. So the first capturing, or the first identification which is done, is whether the sensor could capture the required information or not. If not, then it rejects, and then you have to reacquire the data. So the first step is data capture using biometric sensor. In the next step, what we do in the traditional based system is we do signal processing. As I said, liveness detection, which is also called as detection of artificial molds, is not there. So we go with the signal processing subsystem, and we check the quality of input of a live finger. Then we segment, we extract the feature. Segmentation is done, feature is extracted, a reference is created, and if it is the first time, the reference is stored in the database, which is also called as data storage system. The reference is stored with some, again, different security measures. And now comparison happens when you are re-verifying. So when you go and re-verify, for example, anywhere, if you have to do your Aadhaar KYC, you use your thumbprint, and your Again, the thumbprint is being captured. If the captured biometric sensor captures all the ridges, it acquires, it accepts, and your comparison is done. Where again signal processing is done, the data which is already stored as a reference for you, they both are compared in the comparison subsystem. Comparison is also done and the score is generated. So as you can see, it's an image. So image to image comparison is done. If both of them have a score which is beyond certain threshold, then a decision is made whether there's a match or there is not a match. If you need to accept or you need to reject. If your biometrics are aligned, if your biometrics are matched, you have access to the system of whatever information you are trying to access. Here, the problem which we face, we said the problem is this system did not capture anywhere whether a mold is used or not. Whose fingerprints are, whether it's of an individual or it's of an artificially created mold. So here the problem with the traditional system. Now we see, as I said, the missing block, which I call it as a liveness detection, whether it's a live person or a fake person, it's similar to that information. So we'll see what can be done in that area, which is our main prime objective. Understand, to approach any problem, all the problem sets which you have for a hackathon, you have to understand the idea behind the system, what the problem is. Basically, if you know the knowledge, if you have the base knowledge, if you have the working knowledge, then you would be able to come up with the solutions. Solutions can be come up only when you are actually either using the system and you know what the problem is, or you understand what the problem is and how you can tackle the solution. So it was very important to know these small basic things before we go ahead. And now we are coming at the actual liveness detection module. As I said, liveness detection, there are different terms which you will find on internet for the same concept, for the same thing. There are different terms, which is also called as utility detection. It is anti-spoofing, artificial mold detection, real fake fingerprint detection. So many papers, research papers you will find. Get ideas from those research papers, and it is the time to convert the research which somebody has done to a reality where we can use it for our security systems. So as I said, liveness detection, where we will capture the biometric and see whether it's a live person who is present at the time of capture or not. So liveness, or we call it as whether the fingerprint is not a secret. It is a fingerprint which is a real biometric and not a replica. So it's very simple. It's a two-class problem. If we talk in terms of AI and machine learning, it's a very simple two-class problem. You just have to identify whether the information being captured is a real or a spoof. You can take it as a two-class problem, and you can come up with all the possible algorithms which can be used for the two-class classification problems. Okay, so if we talk about liveness detection, I'll tell you there are things which already exist in the market for the same purpose, but may require a lot of things to be improved. These all are at a very traditional level. You know, there are different sensors. The sensors which a normal fingerprint, whatever we have, they rarely measure the liveness. The sensor cannot detect whether it's a live fingerprint or not. So you can come up, or there are possibilities of having a hardware-based solution or a software-based solution. Okay, so in hardware-based solution, what will happen is you need some sort of similar design which is already available, but in that you will have to integrate some other sensors. And what sensors can you integrate? We'll come to that. So hardware-based solution we can have a software-based solution. In a software-based solution, what we can do is, you can use all your AI algorithms in software-based solution. where we'll come up with those algorithms and how can we use. I'll talk about those when we talk about software-based solution. In all of these, there's one thing which you have to make sure is there should be a liveness inherent to biometric. It should measure the some live parameters. It's, you would have seen, if you research, if you Google, you will find that you can capture a lot of your bio data, like your medicinal, maybe medical data, by using a fingerprint, by using your skin, by using a lot of other patterns, not only rich patterns, but you can capture a lot of other biological parameters or biological things using your fingers. And that particular thing, if you just go and nail it to identify, it would be the complete solution for all the possible artificial molds which you have. I'll give you a trick also. What all things, what all patterns, what all biological patterns you can use. Somebody who's going with a hardware-based solution, you can actually use a lot of biological sensors other than the optical sensors to identify whether it's a real or a fake, or maybe an artificially molded fingerprint, or it's a real one. It's a real person. We'll talk about hardware-based examples, and there is one which is Lumidigm J110, which is an anti-spoof scanner, and you can see the scanner which is right there on the screen. It is a multispectral imaging which uses different illumination techniques and polarization. It's again using an optical sensor. So what I'm trying to convey to you is, along with the optical sensors, why not use a biological sensors to also capture biological information of a certain person? For example, with your thumbprint, you can capture your pulse. Everybody knows what pulse oximeter is, right? Everybody knows what a pulse oximeter is. And obviously, if you are using a silicone mold, you will not have the same kind of pulse reading with a pulse oximeter. The same pattern of a pulse. You read about pulses, pulse oximeter. So the information of what we say SpO2, which we all know, which we all were capturing, we can use those parameters. You can also capture your blood pressure. You can capture odor. You can capture odor with your fingers. See, these are different techniques which you can, and you only need a sensors for all this. If you have, you can also capture your ECG. You need ECG sensors to capture ECG from your, and you can also see the cost effectiveness. The sensors used for pulse oximeter and temperature, these are biological sensors which might not, obviously these are not costly, but the odor sensor is a costly one. So all these techniques, they can be integrated very carefully. So a spoof of a live, whether it's a spoof or a live, and if it's a spoof, it will not have an odor. The odor of a spoof will not have the same pattern as an odor of a human. Every individual have a different odor. If you come and sit next to me, sometimes when we go, we say that, oh, your fragrance is, I like your fragrance. Even if they did not apply any deo or any perfume, but we see that I like your fragrance. That is because we radiate a lot of information out from our system, from our fingers. I'll also tell you a software base. We'll come up to that later. But lot of biological patterns you can capture using your fingers, using your thumb, using your other four fingers. So you can combine these patterns with the light absorption. You can combine these patterns also with the existing optical patterns to identify whether a spoof is being done, whether the attack is being done or not. There's one area which I feel, if you go with, if you go in this direction, you will have lot of ideas coming up with you. Blood pressure, obviously a blood pressure. I don't, with a mold, you will not have a blood pressure. You will not have a blood pressure with the same pattern. See, blood flow, blood volume, there are so many other biological patterns which you can use for the liveness detection of a fingerprint. So that's one thing which you can combine with original thing and come up with different solutions. I'm talking about hardware-based solutions. The same example which I have shown you on the screen, which is hardware multispectral, the small box which you saw there. It is a hardware approach which is already there, but it is using illuminization and polarization technique, which is again optical sensors only. But I only used optical sensors in a different direction, different polarization techniques have been used. So it's a multispectral imaging, high resolution imaging, which we have. Here we have multispectral imaging where it will capture more polarized fingerprints. And if you see, a spoof will not have the ridge lines from all the patterns of your fingers. No, the spoof will only capture basic ridges. It might not capture in a different various angles. So that technique they have used, and the advantage which they have got is they have come up with an MSI sensor which is very, very sensitive to texture of your fingers, and those sensors they have used for carrying out this process of biometric authentication. Again, I said there's a trade-off here. It's a larger, you saw the picture, it was bulky, and it is an expensive thing to do polarization and then have a sensor which captures your texture, highlights area. So these are all very expensive technologies which can also have certain loopholes. So we will see, and that's one focus area where you can go through. You can come up with a hardware solution. And biological sensors, make in mind, if you try to capture biological sensors along with the optical sensors, I'm sure there would be a very strong solution coming up for the problem which we are facing. We'll come up with the next thing, which is software-based solution. And here is the thing which has tremendous area where is of scope for everybody to go through. But less, even if you don't have, like for hardware, obviously you need to have some kind of costing available for you. But for software-based, usually there's no cost, because the technology which we use in today's world is Python, which is all open source. We rely on open source technology for at least POCs, and then later on you can go ahead and build up the idea, create a wide product out of it. But to generate POCs, it's a lot of things which you can do. So the first thing which you can I just propose few solutions with this, or few area of interest or area where you have to think for the solution. As I said, I talked about skin deformation. Your skin, obviously there are ridge lines, but there are skin deformation which we cannot see through our naked eyes, but we can capture them. Or if we take a high resolution picture of scan of this, we'll be able to also capture the patterns of skin deformation. We can also capture elasticity, how much elastic your skin is. You'll talk about, you'll be like, elastic skin. Yes, skin has a property of elasticity, and we can measure the elasticity also with a software. You don't have an elastic sensor where you will sense all this. These are software based, where you'll have to understand the pattern. The ones which we talked about, temperature, blood pressure, etc., all of these are sensors which you can get it. That's why they went into an hardware. You don't have to code, you have to just integrate the hardwares. But here you'll have to code and identify the patterns of the skin deformation. If you will observe, there are valleys and bumps in your skin region, and those valleys and bumps can be captured also, or can be detected with along with the existing fingerprint pattern, whatever we have, along with the ridge patterns which we call pores. I tell you, if you are able to detect the pore of a skin and a sweat gland inside the pore, nothing can beat you, because a mold will never have a sweat. A mold will never have a sweat. A sweat is already only in the skin. And when the sweat is only in the skin, if you're able to detect a pore and a sweat from the fingerprint scans which we have, nobody can beat that, because it's a state of an art technique which somebody can come up with. You can, as I said, perspiration patterns, sweating patterns. Sweating patterns, how you sweat, from which pore regions you sweat. Not all sweat glands are active. Even if we say we don't have a sweat in our fingers, but we have. Internally, we have sweats, which cannot be felt. But when you click a picture, you can see that yes, the sweat glands are activated. So if you combine these patterns, combine these techniques with an existing one, I'm sure there'll be a lot of solutions already with some people's mind that yes, we can do this also. See, traditionally, even if you are applying an AI and machine learning algorithms, but it's again on the pattern. What kind of a pattern are you extracting? And with all the solutions which I'm giving you, or the ideas which I'm giving you, with the focus areas which I'm telling you, you also have to make sure about the data. We'll talk about the data, how you can capture the data, because this information will require you to capture a lot of data which might not be available rightly, I mean directly, but indirectly you can combine certain data sets to get the required information uh, for your ideas. You can use power spectrum analysis. Again, these are software based techniques. You can code, you can actually check the radiation patterns, the power patterns, or we say heat map in technical terms. We can also check whether the noise, how much of a noise or disinformation is there in the valley is a region, I said, when a finger is not a smooth surface. It have curves in it. There are bumps, there's a valley. So we can also see the noise pattern. Silicon would be smooth surface. Dough is a smoother than a skin. Chips are very harder than a skin. They are very rough. So these noise patterns, the surface patterns also you can capture. And the best part would be to combine these features. Do not rely on one technique. Combine a lot of information together and try to come up with a combination of the solutions. Multi-level information you can capture, and you can use that multi-level information for, then you can train obviously an AI on this. So extract these patterns. Once you extract these patterns, you can train AI models, you can train machine learning models, any model, because it's a two-class problem, and a two-class problem is the easiest problem to solve. As I said, we have dry, moist, variable, with age, with ethnicity. These are the life subjects. All these will vary. The another thing which I also want to tell you, the software based will always have a reliance on the property of a spoof materials, which we saw at the start. Spoof material, what kind of a material is being used, that information is the software base will be relied on that. Every material will have different patterns, and every pattern your algorithm has to learn. So it has a reliance on the properties of the spoof material. Also, we always have to think one step ahead of the attackers. When you are solving a security or any concern where there's an attack, any problem where there's an attack, you always have to go one step beyond them to upgrade the system, to upgrade the software, and think in the possible directions how an attack can occur. So you always have to be one step beyond them. The diagram which you can see is actually a denoising problem, where you're capturing the noise with your fingers, and you can see the pattern. If there's a green pattern and a red pattern, so every material will have a different noise pattern. And I'm not saying to only rely on pattern based. No, after the pattern based, you can go extract the features. I've listed out n number of features which you can extract. After these features, get help of AI, get help of machine learning algorithms, get help of a lot of things which you can do for identification. So it is again another layer, whether it's a life of a spoof, not just based on pattern, but we are also making a model learn these patterns. Just don't stop. If you are going with a software or a hardware, both of them, make sure you train some model, a model which will capture the information. And I'm sure if there's a model, and then you can integrate the different another process, the traditional process also, parallel processing, serial processing, how you have to do, you have to come up with the solutions. I have listed down 4, 5, 6 examples which you can use for software based. You can do all of them serially, or you can do all of them parallelly. There are different solutions which you can come up with. Just think beyond what are the possibilities you can explore, and list your ideas. Get into the right direction and get the ideas, and I'm sure this information would have diverted your mind. It's not just based only on images or the patterns. We can also do a lot of other things, with just the biometric authentication or the fingerprint scans. One software which I would tell you, I was talking about Valley, right? So there's one example which I'll give you is a rich and a Valley feature. So rich signal, rich feature, everybody knows, because the traditional method is to identify a rich feature. Now, along with rich, we are also identifying the Valley patterns. Valley, as I said, it is based on the dips which we have. I just zoom into the image. It is based on the dips. A ridge signal, it's a ridge line, you can see the ridge line, ridge patterns which we have on the screen, and a valley signal. A valley signal is a signal where I told you it will identify the disinformations in your skin. Disformation of skin, how the skin texture is, and the valley signal can be extracted from an image. Both of them can be combined together, and that signal can be identified whether there's a spoof or not. See, a live on the screen you can see a rich live and a spoof. The patterns can be similar, can be misleading, but with valleys, as I said, we have a rough hand. Our skin is not smooth. The texture of a skin is not smooth. So a texture of a mold or a silicon or a dough is much smoother than the skin. They won't have valleys, they won't have this deformations like we have it on the skin. All the casting material, it will be very hard, very rough. Again, the valley signals would not be same as what we have on our skin. So we can combine, whether it's alive or not, these two signals together to come up with a software-based solution. I mean, this is just one of the technique, and obviously there would be some minute drawbacks. But as I said, one technique you should not rely on, you will combine, because some solutions drawback would be an pro or an advantage of some other solution. So come up with an ensembling techniques of feature extraction also, of pattern recognition also, and also of models. Come up with ensemble models where you can, and whether you want to do it serially, parallelly, you can combine a lot of techniques for just detecting in artificial modes in the fingerprints. Again, once you have all these techniques, it is very important for an assessment. How to assist of spoof vulnerability, whether a system, whatever system you have developed, whether it is vulnerable to spoof or not, and what countermeasures you can do. For example, you came up with an idea. You have to check with the vulnerability of your system as well for spoofing and other things. So you need to evaluate. Assessment is very important. Whenever you come up with an idea, do assess your idea, and if there's any vulnerability, how you can countermeasure. These things should also be there. If your system, whichever you are developing or whichever idea you are submitting, if it is vulnerable to a spoof attack, you have to check how often it is accepting the spoof. And the first assessment criteria for that is to present acceptance of a spoof finger. How much of a spoof fingers were accepted by a spoof attack? And what countermeasures can you do? Can you restrict the scope of an anti-spoofing module? What do you do? Either restrict the scope and see that this particular module can be only used for so and so conditions, or what you can do is you can go up with a trade-off. You can improve or combine other methods. As I said, one method will not be sufficient. You will have to come up with 2-3 ensemble methods for your detection of spoofs or artificially molded fingerprints. And again, you will have to do a performance assistance, or when you combine them, you again check with the measures and apply a countermeasure to come up with a better solution. And now, as I said, I will give you one. There are many n number of solutions which I can give you, which I can explain you, which I can let you know. But as I said, it's a sample solution which I'm putting up on the screen, where you will have a human sensor, capacitance sensor, because it's an optical sensor, and it will sense your finger ridges. Then you can connect an infrared light in the sensor. So there's an optical sensor. In an optical sensor, you have also placed an infrared light. So it's NIR, near infrared light, or any kind of infrared light, which will scan, and which can also scan the chemical composition. I am giving you this. You can also, as I said, odor, right? Odor comes from the chemical composition of anything. So you can also identify chemical compositions using infrared lights. Different areas you can combine together. So I'm combining a sensor, I'm combining a near infrared sensor or a light, which is actually laser light, near infrared light. So I've captured the optical sensor, which is the ridge lines. I have also captured the chemical composition using infrared light, and I'm combining these algorithms. I'm combining these two algorithms and analyzing the distortion of an image and the ridge lines. So chemical composition is there. I have a ridge line. I'll combine these two and then give up a solution. Give up whether I'll accept or not. So chemical composition can be done to accept whether it's alive or not fake, whether it's a person or a not, whether it's an artificial mold or a live finger. And then you can use the ridge pattern for biometric verification. You'll have to combine different techniques. As I said, once you have the features with you, do not just stick to those pattern-based techniques. Do lot of algorithms for your, you can use a lot of AI algorithms for this. And I'll just tell you, I have just listed down a few, and one of them I will be training also. One of them I'll show you a live demo code also. But let's just understand the process. You have an input which you will capture. A fingerprint you will capture. With the fingerprint, you can obviously, if you're doing a POC or if you're doing an idea, you will not have much of a data available with you. You will have to augment the data. Once you augment the data is something where you will have to create replica of the data set. So you'll have to augment the data set and then extract features. Augment this is we will just create a deduplication of our data set. We'll create duplicate data sets, and then we will increase the size of our data set. So one thing, the process would be to augment your data. Then the next thing would be to extract features. It would be based on, there are so many features which I have listed here: BSIF, LPQ, WLD. This is based on patterns which is there on your fingers. Okay, based on a lot of patterns you can generate. As many features as I said, generate features using any technique. You can use AI to generate these features. You can use GANs to generate these features. You can use signal processing to generate these features. So these are traditional features, along with if you are interested for a biological biospeakers or biological sensors, or you're extracting biological features, whatever feature set. So you have a feature set, you concat, or obviously if you have a lot of feature sets, you can go with PCA, you can go with some techniques, some algorithms which will play around with your features and reduce the number of features. Okay, not actually the information will be lost, but some features which you might feel is irrelevant and is not relevant. So do a feature extraction also, and then create a model. There will be n number of models which you can create. I have listed down a few on the screen, but you can create n number of models, which is neural networks. You can use convolution neural networks. You can use transfer learning with VGG, which is a Google network. You can create your own network. You can create your own network, and also you can use simple neural networks with the additional features. You can use SVM. It's a two-class problem, right? You can also use machine learning problems. You can use SVM, which is a support vector machine. So the combined architecture looks like you are inputting the system, you're training the model. So at the end, you have trained the model. And the model train will ultimately give you a two-class problems. It will give you whether it is a live finger or fingerprint, or it is an artificial mold. That's the end solution it will have. So I'm not giving you one solution. I'm just giving you a way of your ideas which you can progress. You can choose the features, you can choose the model, and you can choose how you are going to sense. You can combine hardware and software together to come up with a nice, ideas, and you can build your own system. So that's one architecture which I have just put it up on the screen for you. So ultimately, as I said, the system which I showed you at the start, now the system which you will make or you will come up with would be very similar, where I had this module deactivated, and then now if you come up with a solution, the solution would be where you have to activate these modules. So the fingerprint, again I said, whether you will go parallel with this or you will go series with this, it is up to your solution, your idea. You can go with the both. The one which I have shown on the screen is a serial representation, so you have to go one after the other. You can also go with a parallel system also. So the data which captures at first, okay, you can put live or you can put a spoof. The biometric sensors will capture the biometric information from the fingerprint or a mold, and then it goes to a presentation attack detection system. Again, the same criteria, where we have a liveness detection module. The liveness detection module is the solution which you have to come up with. And your solution will either accept or reject. If it is accepted by a liveness detection module, it will go ahead for signal processing and verification and match. If it is not accepted, it will stay there. It will reject. So there is no steps being carried out after that. So this is the module where it will either accept whether it's a live or an artificial, and then it will pass through all the signal processing steps you will do, obviously for a match verification. Once the match verification is done, you are either given a decision based on the score to accept or reject. This is serial. You can do it parallelly also. You go ahead with the matching process and go ahead with the liveness detection module parallelly. And then when you're comparing, compare both of them at the end. If any one of them fails, the system does not give you access. So parallel serial, it depends on the solution which you have. The one that you see is a very simple sample solution, the schematic diagram of how a flow should be or can be. I hope not too fast, and I hope you get some information, some ideas which are popping up to you, because I'll be showing you a short demo on the data set, which is an open source which I have used. Obviously, the data set which you will be using, you can find a lot of data sets, and what the data set contains is the data set which I'm using. I'll just show you the project code which I have. I am using SVM today. So after identifying the local patterns, see, I'm not going with a very sophisticated, very hard, very solutions which will require a lot of time, because I don't have much time to run the code. So my code would be very simple. As I have explained, the demo code would be where we will extract certain features from the images. Those features will train on those features, we'll train an SVM model. SVM model will then give you whether it's a fake or a live. So that's one of the demo code which I'll be showing. I'll explain you the code, what code does, and also we will see a short in the demo where we'll see how it lets you know whether it's a fake or a real system. I'll just switch to my demo screen.
So this demo screen, like it's taking time, Karuna ji? Not able to hear you. Hello, can you hear me?
Yes, I can hear you. I'm just sharing my demo screen.
Yeah, okay.
Is my screen visible?
Yeah, it's visible now.
Yeah, okay. So again, I said, since we will be using I'm using an open source technique. So Python is basically used for training models. You can use any language of your choice to write your codes and submit the solutions. First step is to identify patterns. Whenever you give a feature input to the image input to to a scanner, you get features. So you get an image, and from that image you can identify patterns. The patterns which I'm identifying is a local binary pattern representation, which is LBP. You would have seen on my screen list of features which I had. This is a traditional pattern. So I'm identifying a local histogram based pattern. I have built up a class which will extract the features, local binary pattern features. And that feature, there's a Python library skimage which will help you to extract those local binary patterns from an image. And then those patterns, once they are extracted, binary patterns, because the captured information is grayscale, it's black and white. We are not capturing colored information, so we're capturing black and white information. That's why we extracting binary features. And once the binary features are extracted, I'm storing the features. The features are stored, so you can extract n number of pattern features. I'm extracting binary patterns, just simple patterns, and then you create a model. I'm using SVM. SVM is the best so far machine learning model for a binary class. So I'm using SVM model to train on the patterns being generated. So I'll generate the patterns, descriptor will, and the labels, whether it's a fake or a real. So I have an information, I have a data set which is telling me for a training of the model that this is a fake molded fingerprint and this is the actual fingerprint. So I have this information with me already. I have the labeled data set. So when I have a labeled data set, I can go with supervised learning algorithms. And that's what I'm doing. I'm going with an SVM model. So you will see on the screen the code which is there. It is just training an SVM model with the pattern. So I'm identifying the pattern, the descriptors, training the linear SVM model. So it's a classification task. So we will go with SVM classifier and we will fit the data and then we will see the score. So I'm going to run this for you. And the training is being done. I already have the data set stored here. Data set, the structure I had already shown you. It consists of the testing and a training data set. Training data set is fake live, where I know that this is a fake and this is a real fingerprint, live fingerprint, or this is a artificially modeled fingerprint. And once the model is being trained, I will use the model to detect whether it's an artificially molded fingerprint or whether it's a live fingerprint image. So that model training is being done. I'm saying it's okay. The model is being trained, and you can see with a very short. I've yet not pruned the model. I've yet not done analyzed the model. A lot of things which I can still do just with the local based features. I have a precision of a model as 1. Even though my recall is less, I can work on recall. Precision is the true images. The true ones is 1. Recall is less, accuracy is 78%. But precision is 1. So if my model says that it is a real image, it is a real live fingerprint, it is a live fingerprint. Okay, if a model says it is a live fingerprint, it is a live fingerprint. That's what my precision score tells me. So my precision, I can work on recall. Recall is a negative ones, but it is okay. Understand, if you're developing a security system, it is okay for the system to sometimes reject the actual live fingerprints as well. It is okay, but it is not okay for any of your system to be able to give you an authentication when you are a fake. So it's very important your system should be precise. Precise, that means a true positive should be a true positive. A true positive can go to a true negative. That's okay. To a false negative. That's okay. I'm sorry. So if it is truly a fingerprint, it has to say that it's a truly fingerprint. All the fake ones has to be 100% said that fake. If the true ones are classified as fake, it is okay. It's just like, we are being a preventive measure. We have to prevent. Okay, as they say, prevention is better than cure. So we have to prevent. So we'll be preventing. That is why I stick to this model and I go ahead because my precision score is 1. And with just a small machine learning model, we have this. And I'll show it to you one with an image, a print with an image of a fake fingerprint and how the model classifies it as a fake. So I just run this and you can see the scan or the print which we have. Whereas you would say, yes, it is somebody's fingerprint. Whereas maybe a scanner would say it's a fingerprint, but your algorithm is saying it's a fake. And it's a fake because there are some patterns which your algorithm has understood, and it has local patterns. Local patterns are just on the screen. Imagine when you combine biological patterns with this, your system would be robust to identification if the mold is being used or not. And I'll also show you a live for the testing one on the actual fingerprint, and you will see that model says that it is a fake because I said my model will sometimes classify the true ones as fake, but my model will never fail to classify a fake one as a fake. So this model will surely classify that whether it's a fake. If it has said that it's a fake, it's a fake. Whether it has said it's a true, it's a true. So sometimes the rejection for the true ones would be there, but the false ones will never be passed through the system. That's what you have to keep in mind whenever you are training any model or using any building up any system with feature based thing. And I have the last thing, which is the conclusion. And I would just say that at the end now, after me showing you a little idea, a little broad picture of what we can do, it is your turn to come up with a solution. The questions you can ask yourself, and if you have found this useful, you can comment on the section. You can, I'll be there to guide you even after this. And the new ideas which you are there, we're looking forward for those ideas. A lot of things which you it's just my thought process. Understand, when you work in a team, there will be different ideas which will also come up along with this. So it's not just you have to follow this, but it's an idea of how you can approach to a problem statement. And that's what I have given you. It's not a compulsion to follow this, but an idea from my side to help you to broaden your mind and to see what all possible solutions you can come up with, what all possible ideas you can explore and come up with a better system, a robust system to identify an artificial molds, whether for a fingerprints. That's it from my side. Sir, over to you.
So, thank you, Karunaji. I think it was a wonderful session. And though we got some less viewers, the reason, like, let me just tell you, the reason is like it's a class timings and the students are busy with their classes as well. So that's the reason, like, we considered this particular session as a recorded one rather than live one because colleges are open. So certainly now what we are going to do, we are going to publish this link on YouTube and we are going to send it to the dashboard of the team leaders so that they can share it to the team members. As far as the questionnaire is concerned, definitely we are going to circulate the same procedure via dashboard so that we can collect the questions and we'll try to like sort out the questions in a way so that you can answer in one go because we also know like you are also a busy personality as stated by Sumit. So, in the nutshell, would you like, I'm having two or three questions, like the method that you shown in the end, okay, the model that you have shown, like, does this particular thing includes any third-party API or only libraries?
No, it's no API, only code, pure code, no API.
Okay, so that is also
No
because
third-party API, no API from Google, nothing. It's pure code.
it's pure code. So I think our participants can easily understand, like that was a major concern that we raised in the beginning. I'm really sorry for that. That no third-party APIs needs to be used. So that should be
Yes.
underlined, and I think our trainer explained it very well, like how you can do it with the scratch code. You're trying to say something, Karnel.
Yeah, actually, we are not sure with what code is there in that API. There might be vulnerability in that API. So we cannot have access to what the developer of an API has written. So if we can avoid APIs, that would be an advantage for us because we know what we have written and we can identify the vulnerabilities. But if there is vulnerability in an API, then we land up into problems later on. Since the matter of security and we're building up a security system, so it's very there might be some cases where you can replicate the API. So even if you feel that you have a thing where you have to use a particular API, you can replicate it because you know what the API is doing. So I would just recommend everybody, do not use APIs. You can create your APIs. That would be again your work, and it would, you know what you're doing in that. With somebody else's work, you don't know what is happening. So that's a gray area where we don't know whether there would be a vulnerability in that picture or not. So we just need to avoid that.
Okay. So as well, thank you, Karuna ji, and I think it was a wonderful session. And later on, we will be looking forward for your availability by tomorrow, because on a one day we are completing one particular session and problem statement. So later on, I got a very good feedback from my seniors that training is going well, though we have to engage some people like on live. But as I told you, the classes are also going on, so we are not going to get the good audience. And though we are not here for the publicity, we are only having a targeted audience of like 18,000 people registered so far as a team leader. So thank you, Karunaji, for your time. And dear participants, do mark your feedback from your dashboards or the email ID provided in the contact section. Thank you. Thank you, Karunaji.
Thank you. Thank you.